Welcome back, everyone. Today we've got a truly fascinating explainer lined up for you. We're looking at a scientific breakthrough that honestly sounds like it was pulled straight from a fantasy novel. We are talking about the literal transformation of biological waste into incredible wealth. Okay, let's dive into this. So, I want to start by posing this core mystery directly to you. Can seaweed actually mine gold? Right off the bat, it sounds kind of absurd, doesn't it? But what if I told you that one of the keys to recovering some of the world's most precious metals isn't buried in some massive industrial mining operation, but is actually just floating off the coast? Or more specifically, sitting right there in the garbage heap of biological processing plants? Just take a look at the incredible paradox we're exploring today. Over on the left, you've got dealginated seaweed waste. This is literally the leftover biological garbage from commercial processing, stuff we completely discard without a second thought. And then on the right, pure, precious gold. The science we're unpacking today bridges these two massive extremes. It shows us exactly how to extract high-value metals from aquatic environments using literally nothing but this organic refuse. Section 1. The Modern Alchemy. To see why this feels like a real-life magic trick, though it's rooted in rigorous biochemistry, just look at the number that absolutely stunned researchers. When this dealginated seaweed waste is dropped into a highly acidic solution, we're talking a pH of 3, it can hold up to 1 millimole of gold per single gram of seaweed. Now, if you're not a chemist, let me put that into perspective for you. For a biological waste product to have an absorption capacity of 1 millimole per gram is a surprisingly massive figure. It means this literal trash is acting as an incredibly efficient, super high capacity trap for precious metals. No way, right? But it absolutely works. Section 2. Why we need green mining. Well, before we get into the microscopic mechanics of how the seaweed actually pulls this off, we really have to understand why this matters right now. As highlighted in a comprehensive MDPI review on sustainability, our modern world is facing a pretty severe crisis. We've got this rapidly growing global e-waste problem, and the traditional methods of extracting metals from this waste or even from natural ores are incredibly toxic. They rely on harsh chemicals, and they generate a ton of heavy metal pollution in wastewater or what scientists call effluents. Because of all this environmental damage, there is a massive, urgent push globally for a circular economy. A system where waste is eliminated and resources are continually reused. Section 3. Meet the biological sponge. This urgent need for a clean, circular approach brings us to our unexpected hero. We desperately need a way to clean up toxic effluents and recover valuable metals without using more toxic chemicals to do it. And, well, the answer is dealginated seaweed. The mechanism at play here is called biosorption. Simply put, biosorption is the process where completely inactive, dead biological materials bind and concentrate heavy metals right out of watery solutions. You can basically think of the seaweed waste as a microscopic gold panner, or maybe like a highly effective chemical sponge that just naturally soaks up the gold ions floating in industrial wastewater. Section 4. How biosorption actually works. Now, what's really interesting about this slide is how dead seaweed actually manages to grab hold of gold. Let's walk through the microscopic journey of a single gold ion. Here's the step-by-step biochemical magic. Step 1. You have gold ions, specifically gold 3 or Au3, just floating around in an acidic effluent. Step 2. These ions bump into the surface of the seaweed waste and attach themselves. But step 3 is where the real alchemy kicks in. Components on the seaweed surface actually undergo a chemical reaction that reduces the gold from its ionic state into elemental Au0. Finally, in step 4, those elemental gold atoms cluster together to form visible colloidal gold particles right there on the surface of the biological waste. It's literally transforming before our eyes. Of course, you might be wondering, how do scientists actually know this is happening at a microscopic level? Well, the researchers in the ACS study utilized a technique called EF, which stands for Extended X-ray Absorption Fine Structure. Okay, actually, scratch that. I know it sounds like a supervillain weapon, but it's really just a highly advanced X-ray tool. It lets researchers look directly at the exact atomic bonds and distances on the surface of the seaweed, proving without a shadow of a doubt that the gold was physically changing its chemical state. And man, this XAFAS X-ray data yielded some incredible findings. Just notice that about 75% of the gold captured by the seaweed had been successfully reduced into completely elemental colloidal gold, Au0. That is a huge success rate. The remaining 25% of the gold was found to be in an intermediate Au1 state. But that begs the question, what exactly was that remaining 25% attached to?
To figure that out, scientists used another tool called FTIR, or Fourier Transform Infrared Spectroscopy. Don't worry about the acronym, though. The discovery is what matters. The FTIR test showed that there were plenty of carboxylate groups on the surface of the biosorbent, but surprisingly, very little sorption was actually happening at those specific sites. So the crucial point is that the EXAFS data revealed the remaining ionic gold was actually binding to sulfur atoms. Yeah, sulfur. Sulfur is the real unsung hero of the seaweed structure, acting as the primary binding site for the gold.
Section 5. A sustainable golden future. And this brilliantly illustrates exactly why scientific analysis at the atomic level is so absolutely crucial. By understanding that sulfur is the binding agent and that reduction to colloidal gold is the mechanism, we can safely scale this entire process up. As the environmental science and technology study explicitly concludes, deogenated seaweed can be used for the cleanup of gold-containing effluents. I really want you to take away that this is not just some neat laboratory trick. This is a vital, scientifically proven tool for real-world green chemistry. We can literally take the wastewater from e-waste recycling or industrial processing, run it through biological garbage, and pull out pure gold. So let's quickly summarize why this specific biosorption process matters so much. First, it extracts precious metals sustainably, completely bypassing the need for harsh mining chemicals. At the exact same time, it cleans up toxic industrial effluents, which goes a long way in protecting our aquatic ecosystems. Plus, it perfectly drives that true circular economy we talked about earlier. And, perhaps most poetically of all, it literally turns biological waste into tangible wealth. It's a total game changer. I want to leave you with this final, provocative thought. We've just seen how deogenated seaweed waste, something previously considered entirely useless, has the precise biochemical structure to mine one of our most precious metals right out of toxic water. So if literal garbage can mine gold, what else are we throwing away right now that could contain the exact chemical properties needed to save our planet? Thank you so much for joining me for this explainer. Keep asking questions, and I'll see you next time.